Okay. Well, Greystone itself is 50% a high volume precision turning company, and 50% we're a high volume plating, anodizing, coating company. We're in one location on the turning, and we're multiple locations headquartered in Rhode Island with a plating plant, our original plant up in Rhode Island at Induplate. And then our second plant was down here in Virginia, where I'm located. Then 2015, we put a plant in China. And then 2020, we put a plant in Poland. So we focus on high volume, challenging plating opportunities, such as, one of the niches we're well established is fuel injectors. We plate about 20% of the fuel injectors in the world because we have such good control of our plating and tooling. We design and fabricate our own tooling. We design and fabricate most of all our own plating lines, and we tend to work with tier one, tier twos, and OEMs. About 2/3 of our business is automotive, and the other third is a combination of medical, defense, commercial, aerospace business. So yeah, we're a company that a lot of the well-established tier ones recognize as they work to move business and processes that there's a greater density of platers over in Europe. They recognize Greystone as somebody who they can bring processes that are challenging over in Europe over to the United States, and we have the capabilities and technical resources to support them. So that's an
Yeah,
initial snapshot.
yeah, and I guess overall your kind of uniqueness is you have the machining and the finishing all in one process, and or is the machining all in each of your facilities, or is it?
Right. No. So our machining is primarily in one facility. And, historically, there was some concern that customers might not, on the plating side, want to work with us because they would see us as a competitor. But our businesses are really mostly separated. There's only about a 20% overlap of the business. And on the plating side, well, on the machining side, that business is so dense and competitive that everybody just recognizes that it's just a very difficult, challenging market for everybody to operate in. And but on the plating side, we're differentiated enough so that we have many of our competitors are our customers and are very comfortable to work with us and know that, we're not going to see an opportunity for plating and then try to go steal it on the machining side. And so we plate for many of our global competitors, and they are happy to come to us because we give them the right kind of support and the capabilities, and we're easy to work with.
Right, right, yeah. Certainly an inherent benefit of having for some of the tiers to have one company take care of the machining and the finishing aspect of it. I'm sure you all, from the beginning, I'm sure that was your goal, was to sell that aspect of it. I'm sure.
Right, right. So for the people who
Yeah.
want to come to us for both, we're happy to provide an integrated product. But for the people who already have machine suppliers that they work with, that's fine. We're happy to plate for them. And, another advantage is that we understand all the issues that can be introduced to the plating business based on cleanliness or smeared over burrs where you entrap fluids and how that can affect the plating process. So we're able to give some guidance to the machining customers and say, hey, this isn't a good surface finish. This isn't going to plate effectively. Sorry, Jesse,
Right.
go ahead. You're
No, no, that's okay. I was gonna say, I'll piggyback off that first, Leaf, 'cause that's a great point. Is what I find with a lot of the tier ones we deal with to be one of the most common challenges is between plating and machining, there's always a lot of finger pointing, right?
Mm.
It's the plater's fault, it's the machining guy's fault. No, it's the raw material guy's fault, right? When you're really dealing with a high precision, difficult process, you know, there are some processes where we need sub-micron precision on plating thickness or nodule formation, you know, flatness of plating layers, and really working together with our engineering teams between plating and machining helps us expedite, you know, R&D of new product development and launches. So that's really a large portion of you know, where the value comes from. I think is there's a lot less. We're finally done with the machining part. We're going to send it out to the plater, and then we run into an issue, and now we've pushed the lead time back another 8 weeks.
Mm.
We're right down the street from each other. And what I was going to say before that, Leif, is it might be good to give a quick snapshot of when I know you gave a snapshot of when we opened the plating plants in China and Poland, but Induplate, or the industrial plating company that became Induplate for short, started in 1932.
Mm.
And do you know what year, Leif, we expanded machining?
Oh, I'm not sure the exact year where we used to do forging and we sold that business and then we got into the machining business, but um, I'm not sure if it was in the 80s or the 90s.
Right. And then, so we were a plating shop originally since 1932. And
Mm-hmm.
a lot of what we were focused on, because Rhode Island and New England is kind of was the plating and jewelry capital of the United States, right? Before it all went offshore. We were really invested in functional plating. So we started, one of our first customers was General Electric, working with a lot of the difficult to plate NADCAP aerospace components. That chrome plating expertise, just being able to do precision hard chrome functional plating, brought us into some of the tougher jobs where we were recognized as an expert really in selective plating, so plating specific areas of discrete parts. We happened to, I want to say we got pretty lucky with buying out the machine shop or forging house that was in Rhode Island. And that kind of became its own standalone business. I don't think we had any overlap at that time, Leif, when we first started machining, for machined and plated parts.
Right.
Mm-hmm.
You know, one thing I was going to ask was, you know, I know there's a great benefit to have the understanding of the machining of how the parts are made, and I think I think you list on your website that you actually, you know, have a, you know, kind of an engineering section, and does that help you all when you're working with your customers and helping them design the parts, knowing that you're trying to sort of, you know, give your, you know, machining expertise and also your finishing expertise
Absolutely.
from the very
Yeah.
beginning, right?
Right.
Absolutely. I mean, we're working, you know, with tier 1 medical customers right now on some very, very difficult to pass testing requirements, where we're working directly with them at the R&D, you know, telling them, here's our opinion based on findings of how we can change the design of the product to accommodate not only the coating, but have better performance in the test. And and that's you know, we have a lot of depth in engineering within our company, which is a little different than the standard mom and pop shop plating houses.
Right.
Right. And so that in combination with, like Jesse said, the tooling that we prefer to have, you know, discrete machine tooling for selective plating. We can do the painting or taping and masking, but we prefer to make hard tooling for that. And then also for the high volume, that we have a whole automation group that designs and fabricates 100% checking machines, loading machines for both for the machining business and for the plating business. So it really helps us to efficiently process high volumes of parts on both sides of the business.
Gotcha. Yeah, I was gonna say, and the China Poland, was that driven by your customers asking you to come there,
Yeah,
or?
exactly. They said we need you here, and we set up the plants there.
Gotcha. Gotcha. Yeah, like I said, I mean, there's a risk involved in that, of course, and the complexity of doing that. But like you said, to make sure you have that relationship with customers, you sort of have to do it. I'm sure it's beneficial, but yeah, I guess for some people that may not be something they would want to do. But like I said, the
Right.
level you all are doing, I guess it was something that you really want to do to keep the customers happy who want you to locate near them or wherever they need to be. Right. I mean,
Yeah, and we wanted to have a global footprint for the
mhm.
niches that we're supplying so customers can have a global supplier with the same process globally and have that confidence and that flexibility and redundancy. So if there's an issue in one region, we have backup capacity and can supply them from the other regions.
Gotcha. Gotcha. Yeah, no, mostly you mentioned early on about automotive, but I did notice you all have even a separate website for arms and defense, and also for medical, right? So you're really,
Yep.
is that something unique that you've been trying to do lately, or is that?
Over the last 5 years, we've been growing those other segments of our business
Mhm.
because we're already pretty well established and known in automotive. So we wanted to diversify, and we've been successfully diversifying. We used to be 90% automotive, and then we were 80%, and so now we're down to about one third non-automotive or two-thirds automotive, and yeah, we want to keep continuing to grow those non-automotive segments just for the health of the business. And so I guess the next general target would be about 50% automotive
Mm.
and continue to grow the non-automotive segments.
Right, right, gotcha. Yeah, I noticed on your site that you talk about I guess the proprietary system of was it I think it was precision plating system, where there's really no human contact, and you try to automate this as much as you possibly can. Is that something that has really been on your forefront of really as much as you can to automate these processes now?
Yes, I can barely hear you right now. It's
Okay,
faded
sorry.
so much that I'm like
Yeah.
can barely hear you over the background noise. Um, But yeah, so our PPS process, we developed that starting with for fuel injectors based on the
Hmm.
increasing tolerance requirements for our customers. So we used to plate, say 8 ± 5 and have about a 1 CPK, which our non-automotive customers usually don't know what we're talking about when we reference CPKs, but all the automotive guys do. And then that was good enough for a long time. And then, gosh, about 15 years ago, oh, we're going to have a 1.33 CPK. Okay, well,
Mm,
our process was kind of on the edge of capable to that level, and we started having to do more visual inspection and more thickness checking and auditing. And then the CPK went to 1.67 CPK, and we said, oh,
mm,
our process is not capable to 1.67. We are now 100% checking, and we were making machines to do 100% eddy current and X-ray checking on tens of millions of parts per year. And
mm,
eventually we were like, this isn't the most efficient way to deliver the value to the customers. And so we're going to evolve this process, and that's leading into the PPS precision plating system. We said we're going to need to move from making contact with hundreds of parts. Then we scaled it down to 1 to 200 parts we call small fixture. We're going to have to make
mm,
contact with every single part because if there's a non-contact, there's no plating. How are we going to check
mm,
that and make sure that it doesn't get to the customer? So we developed the PPS process so that we automatically load machines and trays into machines. Every single part has its own contact, so we know immediately if the voltage is too low, high, the current's too low. it's separated out from that process automatically. And we deliver 2 CPK on things like 3 plus or minus 1 micron.
Mm,
And when we go and measure and check the parts that are sorted out by the process, which is usually less than 3%, 90% of those parts are still good. The process is
mm,
so sensitive that it's
mm.
filtering those out. We go measure the thickness. Hey, they're good parts. So we're really proud of that PPF process, and we're continuing to search for additional applications and customers who need or could utilize that level of control. And I think
Right.
a lot of customers, when they design for plating, they just are like, there's no way we're going to be able to afford that type of tolerance and it'll be cost effective. So they refrain from designing anything that tight because it would be difficult. And so we're working to introduce that to more and more customers around the world and markets so that we can say, you can have that if it'll differentiate your product. We can deliver it. It'll be cost effective. It's not really that much more expensive than our previous processes because we trade off all that labor for higher capital. Um,
Mm,
so it's exciting.
right.
I'm
Well, I
actually
mean,
going tomorrow to a 2-day introduction where we're going to be working to find those markets, working with a global consulting group.
mm. Well, I was going to say, I mean, yeah, and I'm sure you realize this. There's very few other operations in North America that uh, could do that, let alone even attempt it. I mean, it seems like it was I mean, it seems like put you all in very rarefied air to be able to do that for your customers.
Yeah, yeah, and to design that full machine, validate it, and we produce those machines ourselves. So we have 8 of them operating in Poland, 4 of them operating here in Virginia. They've been
Mm,
operating for 5 years, so they're a proven process. And, when I talk with the design engineers from our customers, they say, "Oh my gosh, Lee, this is the best thing, Our flow
right.
shift is so much less, these perform so much better, we really love this new process." So it's nice to see, the guys, the engineers who are designing things really recognize the value there.
Right, right, definitely, definitely, yeah, and like I said, I guess like as you're sort of evolving the company to sort of get more of a diversification, which is definitely needed with what's going on in a lot of the industries, and like that, adding some of these offers. What's next? What are you all looking down the road that you want to bring, as a service to your customers or potential customers? That
Well, Jesse's continuing, he manages the medical market and he's doing a great job and he's bringing that type of control uh, that we have to the medical market. Some of the chemical processes, we're evolving that and using better tools within the plants to better monitor and proactively manage our chemistries. Um,
mm,
we are working with customers where they need anodizing and machining integrated, where maybe it's so selective that you anodize all over and then you machine off parts where it's been anodized. What else,
mm,
Jesse? What else am I missing there?
Yeah, it's a lot of it comes down to what the customer needs and identifying those challenges and how we can resolve it. So, one, for example, this precision plating system that's historically been very high volume, very highly automated process. When going into the medical market, one of the things we identified was uh, medical customers have a tough time controlling surface finish on the inside diameter of stainless steel tubing that they get from their
mm,
suppliers. Whether that tubing's used uh, either reused and needs to be sterilized in between handling, or it's a disposable. There's a lot of things, that the ID roughness of a tube can prevent or limit, uh, design engineers from passing testing, um, whether it's flow through the tube, viscosity testing, and we've seen this with semiconductor too when dealing with precious metals, and very, very expensive chemical baths, they don't want to have any solution stuck on the ID of those tubes used in those processes. So we took our precision plating system. We said, well, we've got this single piece flow process, and we're able to do selective plating and ID plating. And we actually designed a process for ID electropolishing using PPS technology of long medical tubing. So, that's an example of a new process that, customers didn't understand that capability existed until we started working with our engineers to design it. So we can do, we're working on parts now that are about 2 feet long and 100 thou ID, very, very, very small ID, and we're able to electropolish evenly the entire length of that tubing. So that's just, example of what we're doing in different markets and really what we're looking for is for that system in particular, or that technology, or Greystone as a whole, is how do we give engineers more tools in their toolbox to basically design a Greystone process into theirs to make it more forgiving. Some things we're looking at, for example, and we've thrown around, is we're very good with vision systems in our automation group. Maybe there are some parts, like cylindrical parts, where we can use a vision system to measure the OD of that part and then have that programmed into our precision plating system. So based on that OD size, it programs that individual rectifier with the recipe needed to get it to a final dimension, using plating to remove tolerance stack up versus create tolerance stack up. So there's a lot of different avenues that we're going down with engineering from our customers to, hey, what's possible? How do we evolve plating and anodizing and electropolishing and these electrochemical processes to the next step, kind of outside of the tribal knowledge and witchcraft that people claim it to be, right?
That's what I was going to ask you is like I said, what you offer. I don't want to say you're just not a machining company or not a plating. It seems at a much higher level. And how do you all really? Much of a challenge is it to really explain to some of these potential customers or existing customers all that you can do for them, which is well above what a normal finishing operation just might provide them, right? I mean, and for them to see the value in that. I mean, is that a tough task sometimes to really get them to understand what all you can bring to them?
It is a lot of times,
Yes, yeah.
because plating and surface coatings are often by engineers considered necessary evils, right? It's just another process. It's just another thing to get screwed up versus something that's actually can be a good thing if it's reliable, removes tolerance variation. So it is a challenge. It's getting just up close and personal with them and explaining all these opportunities and kind of going through with them. We've gone through with some OEMs and specific systems, and they've said, hey, come in and let's do a workshop. We want to tell you about every one of our coding challenges through perhaps like a full steering system and explain to us how and where we might approach things differently. So, that's one of the areas there where we continue to kind of offer that support. And that's what really gets to the guys who can utilize and design, consider these options in their design up front.
Right, and that's probably one of the biggest challenges is as an applicator, it can be difficult in some cases to get in front of the customers at that high of a level because they're dealing with, the McDermott Enthones of the world, the Benches, the large conglomerate chemical suppliers who are normally dictating, hey, you're going to use this XYZ proprietary chemical bath and you can only approve this system for this type of work because it passes salt spray at these hours and has been tested. And now that's tested and on a print prior to it ever reaching an actual applicator. right? So it's a lot
Mm.
of like theory crafting before you're getting into actual application. So we find that a lot of times when we're working with these OEMs, that hey, we can meet that same specification or even do better for cheaper by
Mm.
changing these design elements, um, because they're dealing, you know. So that's really where it's a little bit of a push pull system where we work together with the OEMs, we work together with the chemical suppliers, but there is always some back and forth there that makes it a little more difficult to get in at the design stage.